Hello students, so now we will do section B of 2003 physics paper, and this has many questions and you have options. You have to attempt any four from this section. So let's take question number 4. The first question here, and what it says is, it says that diagram below shows the ray OP traveling through an equilateral prism of certain material. So what does equilateral means? Equilateral means all the angles are 90 degrees. Oh, 60 degrees. Yeah. So all three are 60 degrees. Okay. And you have to calculate the value of I2 if the angle of deviation is 43 degree. So what is I2? I2 is the angle of emergence. And what is 65? 65 is the angle of incidence. Right. So this is I. This is E. Okay. And then we have to find the value of I2. Deviation angle is given. So we have delta is equal to 43 degree. We have I is equal to 65 degrees. We have angle of emergence, that is to be find out, which is actually I2. So don't get confused. And we have angle of the prism as 60 degrees. So what is the formula? I plus E is deviation plus A, which is delta plus A. Right. So we have to find E. So that will be delta plus A minus I. So we have 43 here, we have 60 here. What happened to this? We have 43 here, we have 60 here, and we have I, which is 65. So you see 60 minus 65 is minus 5. So 43 minus 5 is 38. 38 and 5 is 43 degrees. So 38 degrees is the answer. So what is the ray QS called? What is the ray QS here? You guess and let me know. What is the ray QS? Write in the comments. That is emergent ray. Okay. Next question. Copy the diagram given below and complete the path of light ray PQ. Now I think I'll use some scale, otherwise I'm too good with diagrams, So I'll use scale here. So this will strike on this face because the incident angle is 90 degrees, so ray will not be deviating. Okay. So now we will draw another normal from here, and normal from here will be, what happened to this? Okay. So another normal from here will be here, like this. Okay. And so this angle is 60 and this is 90. This is 90 degree. Okay. Correct. 90 degree is shown like this. So this is 90. 60, 90, 150. So this is 30. So this is 60. So this will do complete reflection because this is more than the critical angle. Okay. Though this will go at 60 degrees on the other surface. Okay. Now, so I think now I'll go back to pen and start writing. This is 90 degree. This is 30 degrees. This is a normal, so this becomes 60 degrees. As is 60 degree, that is more than the critical angle, so it will totally internally reflect. So another 60 degree. And if this is 60 and this is 30, so 30, 60, 90, 30, 60, 90, so this angle is 90 degree. So it is hitting the other surface at 90 degrees, so it will go out as it is. Okay. There's no deviation. I'll try to draw a 90 degree line. So I'll go out like this. Okay. That is how I'll complete the prism diagram. Okay. I'll make one arrow here, one arrow here. Is that clear? So that's how we'll complete this diagram. Now next is uh, because the critical angle of the glass is 42 degree, that is why, because it is hitting at 60 degree on this surface, so it will go totally internally reflect. It will not deviate or it will not go out. It will directly internally reflect. Had this been less than 42 degrees, the critical angle, then it would have gone out in the rarer medium, just outside the prism. But it is more than 42 degrees, so it will internally reflect. It is meeting the other side of the prism at 90 degree. It will go out as it is. Is that clear, friends? Okay. So now, next question. Diagram below shows two parallel rays A and B, which is orange and blue. Right now, what do you know about orange and blue thing? You have heard of WebGear? So why do we write like that? So here, as this thing grows, the wavelength grows. So red has the highest wavelength and violet has the lowest wavelength. And where is blue? Blue is here. Where is orange? Orange is. So orange has more wavelength than blue. That means orange has more speed than blue. So C is equal to F lambda. That you know, frequency remains same. So more the wavelength, more the velocity. So velocity of the speed of orange light will be more than blue light. If the speed is more means what? We'll learn through diagram. So we'll draw a 90-degree line from here. We'll draw another 90-degree line from here. Okay, lesser than 90 degree. Now, so that means orange will deviate little lesser because of higher speed. It will deviate but not much. And blue will deviate slightly more. It will bend slightly more towards the normal. Okay. So this is what is happening. So the question was copy and complete the path of rays A and B done. How do the speed of these rays differ? So speed of orange will be more. Speed of orange will be more than speed of blue. Okay. Are the two reference glass parallel? Give a reason. No, they are not parallel because blue will deviate more. Okay, because of lesser speed, orange will deviate less. Is that clear? Now, fifth question. Fifth question says a convex lens of focal length in centimeters is placed at a distance of 60 centimeters. So what do we have? We know it's a convex lens, so focal length will be positive because focal is on the other side. So focal length is 1 by 10. F is 1 by 10. Sorry, 1 by F. Okay. And screen is played at 60 centimeters. That means V is equal to 60 and it will be plus because it is the other side of the lens. Right? I will write focus is equal to plus 10. V is equal to plus 60. So what we have to find? We have to find U. Where should you place the object to get a real image? So we'll use the lens formula. Right? That means we'll use lesser space. 1 by 10 is equal to 1 by 60 minus 1 by U. Right? So that means 1 by U is equal to 1 by 60 minus 1 by 10. We will take an LCM. LCM is 60. 60 1s are 60. 10 6 are 60. So that is minus 5 over 60. That means U is equal to, now we'll just reverse it. Okay. Minus 60 by 5. So that means minus 12 centimeters. So object will be placed before the lens at 12 centimeters distance. So U will be 12 centimeters before the lens. Okay. Now second question is coin kept inside. Now this will do. Yeah. A coin kept inside water of which the refractive index is 4 by 3. When viewed from air in vertical direction, apparent to be raised by 3 mm, find the depth of the coin. So how do you do such questions? You know that formula? What is the formula for apparent depth and real depth? So mu or the refractive index is equal to real depth upon real depth upon apparent depth. Now what happens when you put something in water, like a coin in a water bucket, you would be knowing what happens. The object looks closer to the top because of refraction, okay, because of the bending of the light. Instead of going direct, it is now bent, so it comes like this, somewhere here. So object looks like here, but actually the object is here. So there is a difference, okay. Got it? So how do you make it, right? So let's presume apparent depth is, you don't have to make these diagrams. This I was using to explain to you. Apparent depth is x centimeters, okay, and sorry x okay, and real depth will be more than apparent depth. That is how much more? 3 more. So x plus 3 and we know mu is 4 by 3. We'll use this formula. So 4 over 3 is equal to x plus 3 over x. X is what? Apparent depth. So we'll solve it now. You know how to solve linear equation cross multiplication. 4x is equal to 3x plus 9. So x is equal to 9. That means apparent depth is 9, right? Apparent depth is 9. So what is the real depth? Real depth is 3 more than apparent depth. 9 plus 3 Please ignore my bad handwriting. It is little bad. That is 12 Next question. Okay. So now next is, how is the critical angle related to the refractive index of a medium? Question number B. Question number 5B. So critical angle is reflected. You see, how do we write? For a critical angle, light has to go from denser medium to rarer medium. And what happens? Rarer medium, it actually emerges at 90 degrees. So sin r is equal to 90. Sin I is to whatever, So what we do is, because we are talking of a rarer medium, we always write sin inverse 1 by mu. Okay, sin inverse 1 by mu. Actually, we use Snell's formula. So, sin I by sin r is equal to mu. But we are talking of rarer to denser. Here we are talking of mu of the denser medium. So, we say critical angle C is equal to sin inverse 1 by mu. Mu is the refractive index of the denser medium. Infrared at mu is what? Mu is, चाहिए तो you can write also. Mu is refractive index of denser medium. Okay. Next, infrared radiations are used in warfare. Explain with reason. How much space do I have? So I'll now do it in here with giving pointers. Question number 5A. Why infrared is used? 3. This is 3 of 5. This is 5's third question, third A. So no problem. I'll clean it up. This is question number 5. Third A. Infrared is used for warfare because it is difficult to, easier to transmit across. It does not get absorbed. Get absorbed by the medium. Second thing is, so that is the reason. The second reason is infrared is, it does not deviate much with the medium. It doesn't get absorbed by the medium. Okay, and cuts through the medium easily. Next is, the ray of light is incident at 45 degree. As in the diagram below, name the phenomena exhibited by the ray of light when it enters and emerges out of prism. A ray of light is incident at what is given 45 degree. Equilateral means 60 degree. So what we have to tell, name the phenomena exhibited by the ray of light when it enters and emerges out of the prism. You see what is happening is this is one incident light, okay, and it breaks up into two parts, which is red and violet. Actually, it breaks up into all the light components, which is from violet to red. Violet, indigo, blue, green. You know that funda, right? Vibgyor. It breaks up in all its light components because of difference in speed of these colored lights, okay, and the deviation they suffer. So they go through reflection phenomena, and in that different lights travel with different speeds in different mediums. So red travels fastest, because red is maximum wavelength. Okay, violet is minimum wavelength. C is equal to f lambda. Frequency remains same. So they deviate at different angles. That's why red is the minimum deviation from the normal if you see. Okay. While violet is maximum deviation. Similarly, when they go out in the rarer medium from the prism, they again go through the similar kind of more and less deviation. Okay. If you see here the deviation is less, here the deviation is more. Right. So what happens is this is called the phenomena would be dispersion of light. Okay. State the cause of the above phenomena mentioned by you. That is called dispersion of the light, and cause I explained to you that these lights travel at different, these colored lights travel at different speeds, okay, in the denser and denser medium because of their wavelength. So extent of deviation is different when they enter from rarer to denser medium, from denser to rarer medium, and thus there is a dispersion of light that happens, and that is what is driven by prism. Now next is a block and tackle system. A pulley has velocity ratio 4. Draw a label diagram. What I'll do is I'll try to pull a ready-made diagram. I'm not too good with diagrams. Okay. So just give me a moment. It's taking time. Not this. Okay. This is the one I think. Yeah. Here we have. This is the block and tackle system of pulleys with velocity ratio 4. So how many pulleys do you see? The 4 pulleys. The end pulleys, the mechanical advantage is n times, and velocity ratio is also appropriately worked out. So we have to draw a label diagram of the system. That means here we have effort being put from this side. You are pulling the pulling the string, and then that leads to tension T. Now because the string is same on this side, you will have the same tension T, right? And then it is rolled over this pulley and goes to the other pulley. Here again the tension is T. From the other pulley, there is a fourth pulley it goes to, so there is a tension T. And it gets rolled over and get connected to fixed, and there are also tensions. So how many T's do you see? So you see 4 T's, okay. And what is the weight? Weight is L, the load. That is the weight, okay. So that means effort is effort is T, and 4T is equal to load. So load over effort is 40 over T. So you have a mechanical advantage of 4 times. Okay. Draw a level diagram. What is the value of the mechanical advantage given cooling system? The mechanical advantage I have pulled out. That is 4. Okay. So that's it. This is the diagram and this is the okay. If you want, you can take a screenshot or something, and that should give you an idea. Okay. Great. So now we'll move on to question number 7. Okay. Thank you. Hi. So we finished question number 6, part 1. Now we are to do question number 6, part 2. Which says the the meter scale of weight 50 gram force can be balanced at 40 centimeter mark without any weight suspended on it. Okay, good. So this is the 40 centimeter mark. Now if this ruler is cut at its center, then state which part of the ruler will weigh more than 25 gram force. So very good question. Let's say that weight of this part of the scale is W1 and weight of this part of the scale is which is 40 to 100 centimeters is W2. Then as we know, presuming this is W1 and this is W2, the clockwise movement should, and we have put a pivot here, okay, should match the anti-clockwise moment of force. Now moment of force is force into distance from the fulcrum, right? So with that presumption we'll begin. So what we are told is W1 plus W2 is 50 gram force, and second equation we'll write using moment of force, which is W1 into 40 is equal to W2 into 100 minus 40, which is 60 W2. Correct? Correct or not? Now we have two equations and two variables. What we'll do is we will put W2 in place of W1. So we know that W1 is equal to 50 minus W2. And this we got from this equation 1. Right? So we'll put this here. So we'll make it 40 into 50 minus W2 is equal to 60 W2. This was our equation 2. You must have done linear equations in maths. Okay, so all of this should be sounding pretty known to you, right? So 40 W2 on this side will become plus. So that means 40 into 50. Now we are expanding this. Minus 40 W2 is equal to 60 W2. That means 40 into 50 is 100 W2. 40 plus 60. So then what is W2? W2 is equal to 40 into 50 over 100. 52s are 100. 220. So we arrive at W2 is equal to 20 G. Right? So W1 is equal to 30 G. Correct? Now question was, which side is heavier? Which part 0 to 50 or 50 to 100 will weigh more than 25? So the answer is 0 to 40. Okay? Or 0 to 50. They had given 50, right? We'll use their word. So we'll say 0 to 50 gram will weigh more than 25 G. More than 35. First question is answered. What is the question B? What minimum weight placed on this meter ruler can balance this ruler if it is pivoted at center? Right? So let's say M weight on this side will actually balance the scale, right? And the scale was previously balanced at 40 mark, correct? This was 40. So there was no problem when you are balancing it at 40. But actually you want to balance it now at 50. So what you will have to do, you will have to put some weight here, presuming that weight is M. Okay. Now you see that M is giving moment of force in clockwise direction, and the original weight of 50 GF, which was balancing at 40 mark, was, the scale was balanced. So that is giving a anti-clockwise movement. Okay, so both the movement should match. Correct? So M is the presumed weight, assumed weight. Okay, so M is at a distance of 50 to 100. That means 50. And that is equal to 50 gram force. That was the weight of the scale. At what distance it is placed? It is placed at 50 minus 40. So this is 10. I'm trying to do it very, slowly so that you can understand. Is equal to 50 into 10 is 500. So M is equal to 500 over 50, which is 10 GF. What is the hurry? What is more important is to understand the question, right? So that is the answer for what weight should be placed on this meter ruler so that the meter is now pivoted at its center. So now if we put 10 gram force here, we can now pivot it at the center. Question number 3. A car is moving at a speed 18 km per hour, accelerates to attain a speed of 54 km per hour in 5 seconds. Okay, first we'll mark the boundary. So this question is over now. Now we are doing sixth question, part 3. Question is, car's mass is given. So what is the mass of the car? M is equal to 120 kg. What is the initial speed? Initial speed of the car is 18 km per hour. Now you know that kilometer per hour is not the applicable unit in SI. So we'll have to convert this to meter per second. There is a standard formula for converting from kilometer per hour to meter per hour. You simply multiply with 5 by 18. Okay. If you want to know why do we multiply with 5 by 18, you ping me in comments and I'll explain to you. 18 into 5 by 18 is 5 meter per second was the initial velocity. And then what happened? It was being accelerated and it attained a speed of 54 km per hour in 5 seconds. So what is the final velocity? V is equal to 54 km per hour, and that is equal to 54 into 5 by 18. That is 3 into 5. 18 3s are 54. You should be very good tables and all. That will save you a lot of time in examination. That is 15 meter per second. You should know tables up to 25. You should know squares up to 25. You should know cubes up to 20. Okay? If you want to be quick in the examination hall. Because you're not allowed calculators, if I'm not mistaken, right? So now question number 1. Question number 1 is, what is the work done by the engine? So we are doing part A. Work done by the engine will lead to gain in energy. There is no other parameter, is gain in Which energy? Kinetic energy. What is kinetic energy of a system? That is half into mass into velocity. That is half mv square minus half m, because this already had some kinetic energy. It had some velocity in the beginning. That is half into 120. What is v? V is 15 whole square minus what was u? That was 5 whole square. Now this is kg into meter square per second square, which is Newton meter, which is joules. So this becomes 60. What is 15 square minus 5 square? What is the quickest shortcut to do this? One is you write whole square of 15 and write whole square of 5. Other is a square minus b square is a square, a plus b into a minus b. That is what I will do. 15 plus 5 is 20, 15 minus 5 is 10. So that is equal to how much? 12,000 joules. 1, 2, 3 zeros and 6 2s are 12. Now the second part of the question is, what is the power of the engine? What is the power formula? Power is work done upon time. Power is work done upon time. So power is, what is the total work done? That is 12,000 joules. Over how much was the time taken? Time taken was 5 seconds. Okay. Actually it is work upon time. So what is 12,000 upon 5? That is 2400, and power is measured in which unit? Watts. So the answer is 2400 watts. Correct? Now we are moving on to question 7 part 2. So this we will do. So again I will put a mark here. This is done. We'll do in another color, no? We should use different colors. So question number 7 part 2. Part 2a. Complete the following nuclear changes. Okay. So what is happening here is 92 E238 is transforming into, we don't know this, and we know 2 He4. So we'll balance out the mass number and atomic number. So 238 minus 4 is 234. 92 minus 2 is 90. So the equation is balanced. Correct? And then it is further disintegrating by emitting one electron here, which is called beta. Okay, so first one was alpha radiation. Helium is alpha particle. Name the nuclear reaction which has the highest ionizing power. Alpha has the highest ionizing power because it has two heliums. Okay. Now that was alpha radiation, and we have to complete the second part is still remaining of question A. So now this 90 Q 234 breaks into R plus 1 electron, which we can say as beta radiation. Okay. It moves at a very high speed, has very low mass, and reflects maximum in a magnetic field. So what will be the mass number, atomic number here? 90 and minus 1 will be, so this will be plus 190. 234 and 0 will be 230. I think thorium is formed, TH is the one, so okay. But that I don't know, they have not asked for. So I guess we'll write like this. Okay. So next question, question number 7 part 3. We are able to see the TV channels clearly when we set TV on auto tuning. Why? Okay, so here what I have done is, these were all theory questions. I have just pasted it below for your clarity. Now I have the image file of this whole thing which we are doing. So if you want to review image file, you may please ask for that in the comment. If you are not able to capture it from the screen, I'll send it to you separately. So question is question number 7, part 3. We are able to see the TV channels clearly when we set TV in auto tuning. Okay. So which phenomena led to this clear visibility of the channel due to auto tuning? Okay, answer is resonance is the phenomena which leads to better clarity. Now what happens is these TV signals are sent as electromagnetic waves, okay, which are actually sort of energy rays with certain electric and magnetic properties. Now if the receiver circuit in your TV has similar frequency as the frequency being transmitted, then the resonance occurs, and that resonance leads to absorption of more energy or more signal or the more waves, and that's how you get better clarity. So when TV set is left on auto tuning, because of resonance you get more clarity. At your level this should be good. Question number B was, define the above phenomena mentioned by you. So when the frequency of the externally applied periodic force on a body is equal to its natural frequency, the body readily begins to vibrate with an increased amplitude. This phenomena is known as resonance. That's the formal definition. Now give us another example of this. Another example of this is air in sound box vibrates with higher amplitude due to vibrating string of musical instruments. This is an example of resonance. Okay, so that was all the three parts. Okay, now back to question number 8. Question number 8 one, that is another theoretical question. So I have pasted the answer here, which I'll explain. Define specific resistance. So specific resistance of a material is the resistance of a wire of specifically that material of unit length. So the formula is R is equal to rho L over A. A is the specific resistance of the wire. So that really depends on. So if you put L as 1 meter and A as 1 square meter, okay, then R is equal to P. I mean R is equal to rho, which is the specific resistance. So specific resistance of a wire of unit length and unit area of cross section is specific resistance. Is that clear? What happens to specific resistance of a conductor if its length is doubled? Now you see here, if you see rho is equal to, what happens to the resistance of a conductor with length? Nothing happens to specific resistance of a conductor. The resistance doubles. Okay, because specific resistance is a constant. Okay, that has nothing to do with the length of the cross sectional area. That is property of the material. Next question. Name a substance whose specific resistance remains almost unchanged with the increase in its temperature. Manganese is one such substance which is highly what do you call that, does not change its specific resistance for per temperature. Okay, so now question number 8 part 2. Which nuclear radiation will travel undeviated in electric field? How can one stop the radiation escaping from a nuclear reactor? So which radiation will travel is, answer this question if you know. Gamma radiation will travel undeviated in electric field. Okay, and how can one stop the radiation escaping from a nuclear reactor? by putting the whole process inside a nuclear reactor, because nuclear reactor are very strong sort of structures with lead and steel walls. Okay, so those are not really, uh, they don't allow it, radiations escaping, So I'll say radiation escape from nuclear power plants. So power plants have thick lead and steel walls. They also have RCC around it, so they keep it, they make it very strong, for radiations to be coming out of it. So which nuclear radiation will travel undeviated? Gamma radiation will travel, because gamma are pure energy rays. Okay, they don't have a mass or anything. Those are like sort of pure energy rays. They are. Beta has electron in it, and alpha are very heavy particles. Okay, now next one. Name one internal source of background radiations. Even water gives background radiations. So majority of background radiations occurs naturally from minerals, and a small fraction comes from man-made elements. So naturally occurring radioactive minerals in the ground, soil and water produce background radiation. Even human body produces background radiations. Okay, with elements like potassium and carbon. Okay, so I don't know, this got smaller, but I hope you can read it or you could record what I said. Find the value of, now we have a numerical here. I mean, I love numericals. So question number 8, part 3. Find the value of current I drawn from the cell. So what do you see here? You see that current flows from positive terminal of the battery in this direction, and then it goes in this resistor, and this comes to this point, and these two resistors look to be parallel, but they're actually in series, because the current that comes here too. So presuming this was current I1, this is current I2. So I2 moves through both the resistors of 15 ohm, 15 ohm. So we can say that 15 ohm and 15 ohm are in series. So what will be the R equivalent of 15 ohm and 15 ohm, right? R equivalent of 15 and 15 ohm would be, they are in series. So R1 plus R2 is equal to R equivalent, which is 15 plus 15. That is 30 ohm. And then they are in parallel with another resistor of 30 ohm. So we can redraw this circuit. Okay. We have a resistor here of 30 ohm, and we have another resistor here of 30 ohm. And across this set of resistors I have a battery which has its own internal resistance of 2 ohm. Correct? And the EMF of the battery is 3.4 volts. So this is 2 ohm. So 30 and 30 in parallel will lead to R equivalent for this parallel circuit will be R1 R2 by R1 plus R2. Don't get confused with the previous R1 R2. These are standard formulas. So that is 30 into 30 over 30 plus 30. That is 15 ohm. Typically, if two resistors are same in a parallel, you simply take half of it. Okay. So 15 ohm is the total resistance of this part. Right. This is 15 and that is in series with 2 ohms. So total resistance of the circuit is 15 and 2 is equal to 15 plus 2 ohm, because 15 is in series with 2. That is 17 ohms. How much is the current? Current is V over I, V over R, I is equal to V over R. Correct? That is Ohm's law. And what is the voltage? That is 3.4 volt. What is the resistance total? That is 17 ohm. So 3.4 over 17 is 0.2 ampere. That is the current. So question is calculate the current. This I have done. I have to calculate the terminal voltage. Now terminal voltage, if you see, is the voltage across this, the voltage which is provided to the circuit. Okay. This voltage is called terminal voltage. So terminal voltage V will be E, which is my EMF, that is 3.4 volt, minus I into internal resistance, small r. That is how we write internal resistance. Internal resistance of the cell is 2 ohm. EMF is 3.4 volt minus I is 0.2 ohm into 2 ohm. So what is my EMF? That is 3.4 minus 0.4, that is 3 volts. This is my terminal voltage. Is that clear to you? Anywhere in these problems you're stuck somewhere, do feel free to ask me in the comments and I'll respond to you separately. Okay. Through comments or voice call or whatever way you choose. Okay. Now we are on question number 9 and we have one more question I guess, which is these are 9 only. Okay, part 1, part 2, part. Calculate the total amount of heat energy required to melt 200 gram of ice at 0 degree centigrade to water at 100 degree centigrade. Now this question we will do. I love this topic heat because you have clear formulas, very simple formulas and you use it. So what is happening here? What is happening here is that you have ice which is converting to water. Okay. Ice is at 0 degree centigrade. Water is at 0 degree centigrade. And then the water gets heated up from. So there are 3 stages of this heating. Okay. I'll draw a diagram. This ice converts into water. Assuming it's in a container. So this is 0 degree ice. I have tried to make some kind of uh, small stones, ice stones, and this is my 0 degree centigrade water. And then I am heating it up further. So what happens is water reaches temperature of 100 degree centigrade, right? It starts actually boiling. Is that correct? You do you cook sometimes at home? You will get to see it. Okay, so you have flames here. Okay, and you have flames here. Okay, and this is my 100 degree centigrade water at boiling point. So in each stage of this transformation, there is heat energy being supplied. In first stage, which is one here, you don't have to make a diagram in the examination. I'm using it to explain this thing to you. In first stage, when ice is converting from ice to water at the same temperature of 0 degree, we are providing heat to cover the latent energy. Okay. So because ice has certain latent energy, we are going to convert it to water at 0 degree centigrade. Correct? So here heat is being used to answer the latent energy part. And what is latent energy? Latent heat is, I will write a statement. Latent heat, I'm sorry for my handwriting. Okay, from ice to water, which is stage 1. All of you are too young, and in fact some of these topics are covered in 11th of CBSE, while ICSE has chosen to put a lot of physics in 10th grade. So but sometimes I think is a little complex for which is mass into whatever that latent heat is, which is given as 336 joules per gram. So what is the, I will call it Q1. Q1 is the heat supplied. So my mass of the water is, or ice is 200 gram and L is 336 joules per gram. So gram adjusts with gram, so what I'm left with is joules. And this works out to, what will be 200 into 336? That will be 67,200 joules. If they wanted, I could have converted it to calories by the standard joules to calorie formula divided by 4.2 or whatever they gave. 4.2. Here also they have given joules, so they have not asked for calories, but joules can be converted to calories. So this was the first part. Now we will see Q2. So Q2 is the heat supplied for heating water from 0 degree centigrade to 100 degree centigrade. Now we are actually heating water. That is my Q2. That is going to be mc delta T. What is the mass of my water? That is 200 gram. What is C? Specific heat capacity of water is given, that is 4.2 joules per gram per centigrade. And what is delta T? Change in temperature, that is 100 minus 0. That is 100 only. Now joule per gram per centigrade means per gram and per centigrade is answered by the two other things. So it becomes how much? 84,000 joules. So what is the total heat? Question was total amount of heat energy required. So total amount of heat energy required will be Q1 plus Q2. I hope I made sense to you. Still you have some questions and you can ask. Okay. Is summation of Q1 plus Q2. This was Q1. Okay. That is 67,000 plus 200 plus 84,000. That makes it 1,51,200 joules. Or 151,200 joules if you don't follow that lakh system of counting. Okay, so that is what it comes to. Now question number 1, this is done. Now we are in question number 2. What is the principle of calorimetry? Now here I have written the answer. This is all theoretical question. I'll explain this to you. When a hot body is brought in contact with a cold body, then heat is lost by the hot body equal to the heat gained by the cold body, provided there is no heat loss in the environment. That is called the principle of calorimetry. I'll explain this with a diagram also. Presuming there is this body, this is the temperature T1, and T1 is sort of hot, this is hotter than the normal, and there's another body which has temperature T2. So the mass of first body is m, its specific heat capacity is C, and its temperature is T. And the other body which you brought, this is mass m2 and this is mass m1. Specific heat capacity C1, specific heat capacity C2, and temperature was T2. Now when you put them together or bring them closer and both are good conductors of heat, they will actually, the junction will arrive at, or slowly they will arrive at one common temperature which is T. So how much heat is supplied? So one which is hotter is going to supply the heat. This guy is supplying the heat, this guy is taking the heat. Okay. So this is going negative, this is going positive. So how much heat will be supplied? M1 C1 into T1 minus T. And how much heat is being taken is M2 C2 T minus T2, because T2 is lesser than T. Okay, so concept is T1 is greater than T, which is greater than T2. So that is the concept of calorimetry, principle of calorimetry. When a hot body is brought in contact with a cold body, heat loss by the hot body is equal to the heat gained by the cold body, provided there is no heat loss in the environment. Presuming that they are all covered by the insulator, so there is no heat loss. There is an insulation here in the system of the bodies. Okay, and there is no heat loss, so this is the heat transfer. Next, name the material used for making a calorimeter. Thin sheets of copper are used for making calorimeter. Why? Because copper is good heat conductor and has low specific heat capacity. So it gets hotter or it gets colder faster. Then you have another question. Which says write one characteristic property the material chosen for making. So specific heat capacity of the material should be very low. So all the three parts are answered in this. This was the explanation, and rough work you may sort of forget it. Just to explain this. Now we have one more question here in third part. Beautiful question. Question number 9th and part 3. And a lot of free space here, we'll use it. So this says the diagram below shows a cardboard on which iron fillings are kept. A wire bent in the form of a loop is seen passing through the cardboard. So this is the wire. When current flows through it, the iron fillings arrange themselves as shown below. Okay, so here what is happening is iron fillings are arranging themselves in anti-clockwise direction, and here they are arranging themselves in clockwise direction. Now we'll use thumb rule. Thumb rule says that if you swirl your fingers in the direction of the magnetic field, I'm not very good with diagrams, okay, I'll still try to make it. Then the thumb shows the direction of the current. Okay, that is the right hand rule. So if you see, if I swirl my fingers, if I move them around in the direction of magnetic field, the thumb says that the current is in this direction. And similarly for this one, B, if you see, and if I swirl my fingers otherwise round, wherein the thumb shows down and fingers move in the clockwise direction, okay, just opposite of this one. So this one was for A, और आप इसी को उल्टा कर दीजिए. You just turn your hand down and see when thumb shows down, the direction of the magnetic field would be clockwise. Okay. So that means here the current is going. Anyway, the logic says the current will go in this direction. And we know the current always flows from positive to negative. So A is supposed to be positive and B is supposed to be negative. That was my first question. State the polarity of the battery at A and B. So A is positive and B is negative. State the effect on the magnetic field if an iron rod is held along the axis of the coil. If an iron rod is held along the axis of the coil, the magnetic field will grow. Why it will grow? Third question. State one way to change the polarity of the coil. I can change the direction of the current. Right? So what I'll do is I'll connect B to this side and A to this side. So change current direction. Okay. Decrease the strength of magnetic field around the coil by decreasing the current. So if you decrease the current, then what happens is magnetic field comes down. It's not in your syllabus, but if you are passing I current through a infinitely long wire or a very long wire, it's mu 0 I by 2R. Okay, the magnetic field around the wire. So this is directly proportional to current. So more the current, more the magnetic field, lesser the current, lesser the magnetic. So that was the end of this section B. I hope you enjoyed it, and I'll be more than to answer your specific questions. In fact, this whole image file I'll save and I'll try post it in the comment or somewhere so that you can get access to this for reference and review. Thank you, and please subscribe the channel. We will try add more and more solid papers. Now what happens is I don't get time. 10th ICSE question papers are lengthy. It takes about more than 40-45 minutes to do each section, and then making a video and all, then processing it, so all of that. So yeah, if you have any specific questions, please feel free to ask that in the comments, and I'll revert to you. Thank you. Have a great day. Hi. I think I left one question. Question number 7th, first part. Okay. So, well, I'll cover it right now. So, question was, which characteristic sound is affected due to larger surface of a school bell? Now, you all of you go to school, right? So, you tell me part of the which characteristic of sound is affected. So, it is actually amplitude. So, the answer is amplitude. Next is calculate the distance covered by the ultrasonic wave having a velocity of 1.5 kilometers in 14 seconds when it is received after reflection by the receiver of the sonar. Now how it works is that the UV ray travels from source to this is destination. Okay, so it goes from source to destination and then it comes back. That's how you hear it, back. Okay, and its velocity is given as v is equal to 1.5 kilometers per second, and time taken is 14 seconds. Okay, after reflection by the receiver of the sonar. So what we will do is we will calculate distance. Distance is velocity into time, and by 2 because it covers the same distance twice. So presuming somewhere here is my receiver. Okay, so sound is going from this to destination, or the point where it gets echoed or where it gets returned, and then it comes to the receiver. So distance is velocity into time. I think this much concept is enough at your stage. So I'll write 1.5 into 14 over 2. That is 10.5 kilometers. Okay. Now that's it. Thank you. No other question is left. I think I'll still check it one more time. Oh yeah, question 8 is also left. Define specific. Achha, this I have cleared. Which nuclear radiation will travel undedivited? This also I have cleared. Okay, what else? No, nothing else is left. Ah, thank you. I'm sorry for having missed this question. So, yeah.